questions as part of this review. When we look at the JSON file, a JSON file is a structured way of communicating data. It can be saved as a file. It is used very commonly to send things across a network. It's used as an interchange format because it's a common format that any system can use to send information between themselves. Like if you were in a manufacturing facility and you were in the bookkeeping department, and over here you're in sales and you have two different systems, JSON can help bridge those systems. So it's a common denominator sort of format. Here we're using it to OpenWeatherMap gathers all this weather data from all these places all over the world, and they send it out in this format because almost any program can understand it and any programming language can understand it. It is shaped similarly to Python. It has two types of data structures. Data structure meaning you're storing more than one piece of information per variable name. So this outside one, we don't really pay much attention to. Well, I guess you do, because this is a dictionary. So this would be the key. Remember dictionaries, key value. So the key is coordinate. The value is, well, the value is actually another dictionary, isn't it? Oh, that's interesting. So how would we pick this out? Let me open this guy up and we'll use an example in from here. We'll find one that's already built in to look at. There it is. Okay, so for instance, in Maine, we have most of your normal weather things that you want to know about, right? So the big thing is a dictionary, right? So data.get Maine, that gets us to this point. And how do we get from the next dictionary? We add another get onto the end of it, and that pulls in this key, which returns this value. So it's a dictionary inside of a dictionary. This is a fairly complex API JSON file, but it's very similar in structure to dictionaries and lists. This one's a little different. It says get weather. Well, there's weather. But for some reason, and I have no idea why, they decided this should be inside of a list. But the list only has one element. And the number of the first element in a list is 0. So this gets the list, which means we are now down to this, which is a dictionary. So then we get description. There it is, overcast clouds. What do you suppose dot title does? Does anybody know what title case is? Title case is, yeah, go ahead.
Capitalize the first letter?
Mhm.
Yeah.
Yep. So overcast clouds becomes capital O, capital C. I just added that in there because I like to have everything in my weather map be consistent. So far, so good. So that's how I found all of these. And the last part of the assignment next week is going to be for you to go through and find, oh, well, this doesn't have pressure. Maybe I want the barometric pressure. Maybe I want the sea level. Maybe I want the visibility. Maybe I want the speed of the wind or something like that. And you go through and figure it out using this as a pattern. You can go and figure the rest of these guys out. Like, is it 100% cloud cover? Well, apparently the day I pulled this out, it was 100% cloud cover, whenever this was. 38.66, so it's probably sometime in the winter, I'm guessing. Who knows? All right. So the next thing, yeah, yep. Oh, I think that was pretty much it. Oh, input. We didn't do input. We've hard coded everything to this point. We're going to get location. And so one way to put in location for OpenWeatherMap is city, state, country. And this builds our weather query. We're looking for city, then state, then country. So we enter city, state, country. The nice thing I like about OOP, I don't have to pass parameters and return things. These are part of the weather object. wherever I want to get the weather, which happens to be there, self.location, self.location. I don't have to pass parameters around. So the query is the part of the information that you're sending to the OpenWeatherMap that says, look for this information for me, please. It also sends your API key and it converts everything in Imperial. If you don't want Imperial,
Sorry.
if you don't want Imperial, you take that out because we're the only country that does Imperial. Well, maybe does England? No, I don't think so.
No, that's metric.
Yeah, everybody does. We're the only ones that do Imperial, like Fahrenheit and that kind of stuff. We're just silly here. And then you have a full-fledged weather program. So my sister lives in Fairmont. Let's see what her weather is like right now. And the country would be US. Oh, it's overcast, 46 degrees, a lot of humidity, which is pretty typical for Minnesota. Lots of humidity and overcast. Yeah, it's pretty like dreary being in Minnesota during this time of year. That's what this one's about. Let me take a look and see if I missed something. Let's see, expand the program. We're not doing that yet, but we're adding rich to it. Yeah. Which we did rich already, and I give you an example of one style of rich to make it look pretty. Yeah, and exception handling, okay. So I have one in here that's done with rich formatting. Oh, this is actually the one. I don't know if it's cool or not. If I added anything extra to it, or I just made it boring. Oh, I didn't do much with that one, did I? Let's try this one. I may have done more and I may not have, I don't remember. Sometimes I go crazy on these projects and sometimes I don't. Hearing, see state of Nebraska, US. Okay, see, I did get a little better with that one. I have sunrise and sunset, wind direction, 148 degrees, temperature, no clouds. Oh, we should be outside. 55 degrees, no clouds, a little tiny. I mean, for here, 9 miles an hour is like a still day for us. It is. Okay. That takes care of the ideas behind this program, which for one of my hobbies is building. I like to build weather programs. As you can see in my weather folder, I have all kinds of stuff in here. I have AQI, I have a moon phase program. I don't remember what some of these are because I haven't worked on them for a while. But I have all kinds of things. I find these little programs like this fun. I like to pull things up. Let's see, moon phase. There it is, moon phase main. This is when I built the TK Enter. I haven't worked on it for, I guess I did something in February, apparently. There. So the moon is totally dark. There's how far we are from the moon in miles and kilometers. There's like a planet library that you can calculate like the distance from here to the sun and all kinds of stuff. So I pulled out that information about the moon. And of course, the moon does not go in an entirely circular orbit. It's elliptical, so it's at different distances. So you could use this same library to calculate where's Mars, how far away is that? You know, that sort of thing. I just thought this was fun. And if you double click, you can check anything out. See, I have little pictures in there. This I was quite proud of. And I got it. I can look ahead. Okay, on November 10th, 2028, it's going to be a last quarter decreasing from full. Because macro objects use Newtonian physics, which means they're pretty predictable. Unless something comes by like a big comet or something and interferes with the gravitational stuff. Yeah, gravitational effects. Okay. Yeah, this is not a science class.